All right, so we're about 5 minutes early, but I thought we'll kickstart, and then once we are at 7, we'll really go deeper into this. But welcome everyone to our Fluid AI Garage. We love talking about AI and the different things, and today we're talking about RAG and Agentic AI.
Yeah, absolutely. I think it's going to be a very interesting space overall, and I thought maybe before we kind of kick off on that, because I know folks are still joining in, we could discuss a lot of other stuff that's happening in the generative AI space, a lot of other interesting upcoming stuff. One of the things I heard read up recently was that NVIDIA is facing a little bit of a challenge with the whole Blackwell chip.
Okay.
So the racks that they put, they're not being able to keep them cool.
Okay.
So the chips the whole rack overheats. And they're doing a lot of stuff, but there might be another quarter's delay, which will both hit NVIDIA's share, but also it's like the whole Blackwell model. They've gone with a very different rack architecture.
Okay.
And it's a lot more complicated. So
compared to the H100 and 200, this is a totally dramatic change.
Yeah. So it's like, if I was to give you the closest equivalent of the world, this is like when the A380 was launched by Airbus, where the plane was huge and very different, and it needed a lot of changes at the airport to support like the bridges and the.
Okay. So there's a lot of stuff that is inherently changed. In this.
They've gone a little all out. So risk, but so let's see what happens.
Okay. And in terms of AGI also, right? I think there have been some statements out there where AGI is much closer than expected. What are your thoughts on that? Like, do you think we are a couple of years away or still large times?
At least what I read is that, yes, it's kind of confusing. Some say it's closer and some say GPT-4 is kind of hitting a cliff. So the Orion, the next GPT-5 is not getting that performance boost that they're looking at.
Okay.
So they actually...
So what is Orion? Sorry.
Orion is the GPT-5, the code name for GPT-5, basically.
Okay. All right.
And they're struggling a bit. So they're kind of trying to figure out whether this is the right, does it need an approach change? Like just adding more parameters, optimizing them. They also tried with O1, the thinking chain of thought architecture. Right? The model thinks through its moves.
Okay.
But they're struggling a bit on the getting that GPT-5 level quality that they promised the world. So.
Okay. So folks, we're just waiting, I think another couple of minutes and we'll start. We were just discussing about AGI and some of the other things that are sort of happening. So I think Orion, which is GPT-5, what Abhinav is saying is a little behind right now, but getting there, right? Getting there quickly.
Yeah. Anthropic's winning a lot of market share.
Yeah, I just read 24%, right?
Yeah. They've come in a big way for sure. I think the reason they say Anthropic's doing so well is because they essentially cracked the coding market. 50% of all GPT use cases are coding oriented. And so what they were able to do is essentially their latest model beats everyone else in the LLM leaderboard, including GPT-4o.
Oh, really?
On coding skills.
Okay.
Right. So Claude Sonnet 3.5. And that's essentially allowing them to take up a lot of the coding use cases.
Okay.
And that shift is where that market share expansion for Anthropic is essentially coming from.
Oh, all right. But in terms of LLMs, right, like Facebook's always the big one because it's open source, and Mark Zuckerberg is just reinventing the entire company around llamas, whatever. What do you think is going to happen there? Because is open source going to catch up, or the closed source LLMs always going to have some sort of lead?
No, open source is actually catching up very fast. In fact, the big guys, like I said, they're hitting this peak. Yes. So the open source guys are really doing well in the market. So there's the Chinese one, Quen 2.5.
Okay. All right.
And that apparently has some great numbers, especially in coding, in a few other things. It's also surpassed, in fact, it's surpassed GPT-4o in certain metrics as well. So you've already reached a stage where open source models are either at par or slightly lower, or sometimes even crossing the proprietary ones. Which means you kind of essentially, the open source world has wiped out the difference, between choosing either or. And if you look at it from a general intelligence perspective, yes, GPT-4o will be the best. state-of-the-art model out there, or an Anthropic Claude will be the state-of-the-art model out there.
Okay.
But when you start saying, oh, okay, if I want a text-to-SQL model, or I just want to analyze it on coding benchmarks,
okay,
or I just want to analyze it on function calling benchmarks,
okay,
then the open source ones are either at par or sometimes even beating the proprietary ones.
okay.
And that's actually, and we're going to talk about it today, but then you actually take a lot of these models and you benchmark and you put an agentic platform that uses the best parts of each model,
okay,
and you put them in a workflow together. Like you can surpass GPT-4o level intelligence very easily.
Okay.
And still have everything running open source. You can put it on-prem, but you have like literally that quality running.
Wow. So you're not paying per transaction, but you have these agents which can do a lot more. And that's what we're going to talk about today, right?
Yeah,
that's a great segue to that. So wonderful. I think, let's get started today. We're going to talk a lot about RAG. We're going to talk about Agentic AI, explain you what RAG is as well.
And how to optimize for it. Like not just surface level RAG, but really go deep into the challenges and optimizations for RAG.
Yeah. I think RAG is something, Abhinav, can you tell us the full form of RAG before we sort of go deeper?
Yeah, so RAG stands for Retrieval-Augmented Generation, which is essentially, like if you look at it, it actually makes a lot of sense, right? And a language model on its own just has finite pre-trained knowledge. And if you can augment it or improve it by retrieving knowledge from other sources, so retrieval-augmented, and the LLM generates the answer, right?
Okay.
So if the LLM's generation is augmented by external retrieved sources, that's what RAG is. Got
it. And in terms of, is this the first step any company should take on their GenAI journey? Is RAG the simplest, easiest, but still highly ROI kind of step, do you think?
Yes and no. So I think sometimes, like if you're solving an automation problem in the organization, right? You're automating 2 steps together, automating a workflow. RAG might be a part of it. It's definitely easier because it's kind of like, it's been there for a while, right? RAG approaches have been there for 2.5 years now.
Okay.
Agentics is slightly newer. There are lots of options out there. So, but sometimes depending on the use case, agentics can also be easier.
Okay.
So like short answer, RAG easier, but not always.
Not always. Okay. Yeah. So let's get into it, right? Let's, we've talked a little bit about all these concepts, but let's really like just sort of see what all of this sort of really, ends up doing for all of us. So, in terms of, we have, so let me just sort of bring up my screen and then let's talk through what we talk in when it comes to RAG, right? But before that,
I think the presentation's still coming up on the screen, so we'll give it a second, and till then we can cover a few.
Sure, yeah. So while it sort of loads up, I think one thing that's been interesting when it comes to RAG is that why not fine tune?
Yeah.
Right. Why do we use RAG instead of fine tuning, and what's the kind of difference between the two?
Yeah. So I think that if I was to kind of elaborate on what the key difference between RAG and fine tuning a generative AI model is you simply RAG. It's like if a student went for an exam, RAG would be an open book exam. So they've got the questions, they've got the textbook where the answers lie, and they're kind of figuring it out on the fly. So that's one approach. And the fine-tune model approach is essentially where you're going to go ahead and do the exact opposite. It's a closed book exam. You studied, you trained the LLM in the past. Now the LLM's been put to an exam and it has no access to anything from the outside world. The difference comes in, if you're fine-tuning, essentially, you kind of have what you've taught it, you're stuck with. So if the textbook gets updated, you need to retrain the model.
Right. And if you want to delete something from the history,
exactly.
That's the problem.
Yeah. So if you want to delete something, information updation, and the thing is like it's gobbled up the entire set of textbooks, right? So if even one sentence. So let's
Okay.
say you gave it like 100 textbooks of fine tuning,
All right.
and one sentence has to change.
Okay.
You have to throw out. You can either train on top of your existing adapter
All
and
right.
hope that it doesn't get confused,
Okay.
or you scrap it and retrain from scratch,
Okay.
which is kind of problematic because content is changing like almost every minute in an organization.
Okay.
Right, newer updates are coming in, newer knowledge is coming in.
Okay.
So what you could essentially do, in that scenario is actually kind of go ahead and how do I put it? Use RAG, because then you can kind of keep changing the knowledge that it has access to.
Okay.
Almost every time, and it kind of becomes very easy to do.
Got it. But so then, Abhinav, is there an either or is there something wherein RAG can be used as a fine tune can be used in addition to RAG?
Yeah, and I'm just gonna do a quick check-in with folks. If they can put it in the chat, are they able to see our screen? Okay. Can we see the? Okay, people. Only. Okay, let's share again.
All right.
Yeah. Okay. Can everyone see the screen now? Yeah. Okay.
Cool. We're good. Perfect. All right. So let's get going, and we always have a maze to start off with. Folks, if you can see the maze and see.
You have to start from the left arrow and end up at the right arrow.
Yes.
And as soon as you solve it, you can say, just put in yes. So you start at the left, end up at the right. We'll see the fastest times.
Yeah. If anyone sort of gets this one there. I think we have a really serious bunch of folks today.
Yeah. No, actually, we have a bunch of very, very smart folks on the call, because the maze actually is unsolvable. So we've often had folks, say yes, have solved it, but it's heartbreaking to tell them that it's actually unsolvable. What we're looking for you to do is either go here or go here, because I essentially said, start from the left arrow, go to the right arrow, but I didn't really say that you need to use the maze or go through the walls of the maze. And that's where it comes to, first principles thinking. You want to question your assumptions, question the way you look at these problems. Kind of like how Elon Musk does first principles thinking when he builds out SpaceX and the rocket coming back. You need to look at Gen AI from a first principles perspective and really not solve these problems by just going into the most complicated or maze approach. But look at fun, easy ways to solve it.
And that's what we're going to do with RAG and Agentic AI, right?
Yeah.
So a little bit about us. We are Abhinav and Raghav, with co-founders of Fluid AI. Our company has worked with some of the largest brands in the world. You can see them up on screen. And we launched the world's first written AI book, right? It was launched in 31st October 2022, almost a month before ChatGPT. It's a bestseller on Amazon. Go check it out. And we have been doing this for a fairly long time, right? So we are the company which launched the AI avatar of Warren Buffett.
Can I say, I looked at this and I said, what does this mean? First ever.
Yeah, so we can just quickly show you how that avatar looked.
Bottom of the screen.
But one of the questions Warren was asked was, and Abhinav, why didn't you tell us that?
Yeah, I think people could hear the audio maybe, I think, because it's going to be
Invest in yourself.
So it was about investing in yourself and really spending time on learning, kind of what people are going to do today, where we'll go deep into these topics and spending time on just learning these concepts. I think that's what AI Warren and real Warren both wanted everyone to know.
So what we thought was interesting was, if everyone studied this company called Moderna, right? It's been a company which was behind the COVID vaccine, and that's trying to behave like a 50,000 people company and just 5,000 people. And they're doing this with Gen AI.
Yeah.
They have literally about 20 to 30 AI agents, which are literally doing different things, right? From vaccine dosages to things like investor presentation. Right? So it's possible today that you're a smaller company, you're a challenger brand, but you don't need to grow at that same level. Moderna is going to do it with 5,000 people, or is attempting to do it with 5,000 people what a Pfizer has with 100,000. And that's what we think this RAG plus Agentic AI can do.
Yeah, absolutely. So this is how we want to structure today's talk. We're going to just very fleetingly cover the use cases, kind of marry them to the different techniques that you can use to solve these use cases, right? You could use RAG, you could use agentic models, you could use multimodal, and then the delivery behind it, right? Should I build it? Should I buy it? What's the approach over there? Because that's a key decision in that process. And we'll go deeper into the techniques as well. So I think just from a use cases, these are some like, support agents, operations agents, sales and marketing agent. We're going to be putting up a quick poll as well. So I'm going to talk about the different techniques that you're going to be able to leverage, and then we'll go deeper into each one of them. RAG, like we said, is Retrieval-Augmented Generation. So you're going to get knowledge in and make it available to the LLM. So you load information. And we've thrown out the poll. So people have said that is agentic more important than RAG? It's about 65% have said equally important. 36% have said agentics over RAG. And about 7% of you have said RAG over agentics. So it looks like it's equal. And then if it is a fight, then agentics would win.
Yeah.
So core concept of RAG, before we go deeper into the challenges and how to solve for them, you take a document set or, document intensive department, how-tos, procedures, manuals, you throw them all into a particular system, like, if you have your PDFs, documents, PPTs, you throw them and load them all into a...
When you mean throw them, Abhinav, do you mean that it has to learn, or is it just a sort of instant retrieval?
Yeah, no, so you put them into something called a vector database.
Okay.
And then the vector database is basically breaking up all these documents into smaller parts and basically semantically referencing or understanding each part.
Okay.
So it's not doing like a keyword search at the back, which kind of pretty bad, right?
Okay.
But you ask a question, it's going to create a vector and then match it with the database.
Okay.
And try and figure out what are the relevant sections to show the LLM at that point in time.
All right.
And so once you do that, you can then have like really powerful interactions, right? You can ask the LLM, how do I do this? What are the last 3 fraudulent transactions? So what's going to happen at the back is, so the question will go to the vector database, you'll get the relevant sections, and then the LLM, almost like a comprehension
So any
test.
LLM, right?
Yes.
Essentially.
Yeah, any LLM.
So the LLM is not that important.
Correct. It's almost like it's a big comprehension exam, like kind of the ones you do in GMAT.
Right.
Where it's like, okay, here are the multiple sources of information, and this is the question. Now answer it.
Okay.
And that's essentially what the LLM is doing at the back.
Okay.
So it's actually a slightly more commoditized layer. What you need to get right is the vector database. The retrieval needs to be great. Okay. The sections that come in need to be very powerful.
Okay.
And you essentially run into a lot of problems when you do this. And this is in fact a good diagram to kind of show you what's happening behind the scenes, right? So this is your vector database. This is your request coming in, right? Your question, how do I'm seeing error code 3021 machine, right? It creates a vector, searches through the vector in a database for, this sentence essentially. How do I
error code 302?
How do I improve the issue for machine X, error code 302?
Right.
Relevant sections will start coming up. That's your context for the LLM. And then the LLM has said, hey, here's the user's question. Here's all the relevant articles or sections of those articles that I found.
Okay.
Now give me an answer.
And that's a well-drafted answer.
Correct.
Okay.
Exactly.
All right.
And obviously the context will have a lot of junk in it and lots of extra stuff in it.
Okay.
It's kind of like a Google search, right? Here are the top 5 links, but now it's actually gone through, read the links and given you, created the answer from it.
Awesome.
Now that's all hunky-dory. I'll come back to this. But there are a few problems, and then we'll tell you why agentic RAG is actually important. So number one is you're going to break up the document into smaller parts, right?
Right, that's how it's going to retrieve.
Yeah, that's how you're going to put it into a vector database. It's going to be able to search the different vectors. You take a big document, create a vector out of it. The searchability of that is horrible. It's not there.
Okay.
Right. I mean, it'll come up in every search then.
Yeah.
So you want to make chunks out of it.
Yeah.
Problem that happens here is I look at this SOP on the right? It's about 10-point SOP.
Right.
Standard operating procedure.
Okay.
And now, so let's say the first 4 points are in chunk 1.
Okay.
5 to 7, 8 are in chunk 2, and 9, 10 are in chunk 3.
All right.
Let's say I ask a question like, tell me about this standard operating procedure and its steps.
Okay.
And the retriever finds chunk 1 relevant, obviously, because it has the title, it has the first points. Chunk 2 or 3 might not turn up.
Okay.
Because it's just like a continuation, right?
There's no context.
Yeah, there's no context. So this might not come up. So the LLM might answer, but it might think, there are only 6 points.
Yeah.
And it might miss 9 and 10.
Okay.
Or it might see 1, 2, 3, 4.
Right.
And if chunk 3 came up in the search, then 9 and 10. So it'll think there are only 6 points again.
Got it.
So you've got incomplete retrieval that's happened.
Okay.
Which is the problem.
But a lot of people say the context windows of these LLMs are increasing. Why not just throw the whole?
Yeah.
Or everything.
Everything.
Okay.
Yeah. So that's becoming an interesting approach, but two fundamental problems. And I think a great point that you brought up, Raghav. So one is you're charged per input token.
Okay.
Or per input amount of size of input you're given to an LLM.
Right.
And you're charged for the output.
Right. Even if it's on-prem, right? Your compute is heavy.
Yeah, exactly. Yeah. And right. If you do it in prem, then it's what they call it's taking up a lot of your GPU to process that much input.
Exactly.
So either way, it gets a lot more expensive, like a lot. So if a query costs you X by using RAG, it could cost you anywhere from 10 to 100X to 1000X because you're just sending the entire context every day.
Okay.
There is a new interesting technique that's come up called prompt caching, which allows you to cache part of that context in the LLM. So it's not redoing that work again and you save cost. But again, like in small change in content, the cache has to be recached. Right? So you've lost everything. So that's one problem. Number two is that while LLMs can handle larger context, you will notice, and you'll notice this with ChatGPT, you can try this right now as well, right? You give it a para and say, okay, you ask it a question, it does a phenomenal job.
Right.
Like you will go right to the nuance of it. You give it a 5-page document and ask a question, it'll do a decent job.
Yeah.
You give it a 100-page document,
it's gonna
be okay-ish. You give it a 1,000-page document, it's gonna kind of know everything, but it'll still make mistakes.
Okay.
Right? So you'll start getting hallucinations, you'll start getting missed context. So you've kind of, and the third, so these two problems, right? Cost has gone up. You're starting to make a lot more mistakes. And the third kicker is that it's going to be a lot slower.
Right.
Because the LLM now has to compute a lot more, the data coming in, doing everything, the cost of doing all of that. And not the time taken, the latency goes up quite significantly.
So you're not going to answer for half an hour.
So slower, worse,
more expensive.
Right. So that's essentially why you would do this.
Okay, cool. So then that's why chunking is important in terms of getting it right.
Yeah. And I think someone's asked an interesting question. Jatin's asking, how is graph RAG different from normal RAG? And we'll get to that in a bit, but that's a great question. So just to cover it, since it's a really interesting question that he's brought up, the difference in graph RAG, right? So this is vector RAG, where you basically created a vector database, or you chunked all your data up and you gave it a vector database.
Okay.
In graph RAG, you would create a knowledge graph.
Okay.
Which is quite a cool concept because you're taking the same content in, but you're saying, so let's say it was an article on Shakespeare, William Shakespeare.
Okay.
And it's
his
like
works,
his works, right?
Yeah.
So then the graph RAG would essentially create a node called William Shakespeare.
Okay.
The LLM would be told, hey, create this content into a graph.
Oh.
And so it'll be like, okay, here's a node called William Shakespeare. And then there'll be a connector saying written. And then it will be like
his works.
Yeah, like
Julius Caesar.
Written Julius Caesar. Julius Caesar will be another node. Then written, another node would be Othello. Yeah, and another node would be Othello. And then Othello could be another node saying actors.
Okay.
Or like main character,
yeah.
lead a character, so and so. Julius Caesar main character Cassius. Cassius, what was his name? So that kind of stuff, right? So it builds that relationship, which is quite interesting. You have things like SOPs and longer documents. You need to use both. Like you can't just use GraphRag. GraphRag is great for you asked a question like, what are all the works that William Shakespeare wrote? Vector RAG would try and get all the chunks, right? Relevant chunks.
Where it's mentioned, Graph would have it properly.
Graph would have it much neater, much nicer. So it'll give a much better answer when you ask these. And you could ask a twisted question, right? Like, what are works that William Shakespeare wrote, but before 1971 or
1700?
1700.
1650.
So my history is fantastic, as you know. So that essentially GraphRag would answer that really well. Vector RAG would try and look up chunks where this is mentioned, but now there's some chunks which are mentioning the year, some chunks which are mentioning he wrote. So then putting it together, the vector RAG wouldn't do that great a job. But like SOP documents with a lot of text and all, GraphRag sometimes the LLM doesn't construct the graph correctly. It messes it up, because you first given it one knowledge, said create a graph. Now here's more knowledge. Now recompute the graph. So the graph RAG can go wrong sometimes, but as an additive, it's really good. So that was graph RAG, and we'll get to agentic RAG as well. So this is a problem. Then documents have things like images, tables, and they're two columnar. So you have to parse them correctly, right? For them to put them in the vector database as well. And how do you parse the image? How do you parse a table?
Got it. So there's a lot of confusion, right? It's not like a single Word document with just text and lines, right? It's two, and there's an image thrown in, there's a table within table, a nested table.
Exactly. And it's nice when you demo, right? Everyone will create that nice little Word document. It's very clean.
Which only exists in the demo.
It only exists in the demo. So it's fantastic. So there's another question, again from Jatin. So, I love the interactiveness, Jatin, so keep that running. So he's asking, is it like a mini neural network of sorts? It kind of is, but neural network is a very complex representation of numbers. Graphs are kind of very simple representation that a human can understand. But conceptually, if you go really meta, then yes, they're both kind of graphs. But they're very different. The next problem is conflicting knowledge, right? Master document says that there are 12 leaves. There's a new document that says, now from 2024, there are 24 leaves. So both will come up in the context for the LLM, right? In the RAG retrieval.
And what does it prefer? Right? Is new master?
And they're usually this is a good example, but it's not always new memo, master document, right?
Update 72.
Exactly. So then it becomes even harder for the LLM to understand or realize. The other problem is custom vocabulary, right? A lot of corporations use funky acronyms for their stuff, and then the LLM doesn't know that.
People have all kinds of strange acronyms.
So that's some of the problems, right? How do you solve for it? So let's go back a step, and I'll show you one way of solving for it is to create an agentic RAG in the back. So rather than doing simple query, chunk retrieval and answer, the query comes in. You first rewrite the query. Why do you rewrite the query is, so an example here, and we'll pause when it goes to this, but an example here of why you need to rewrite the query, right, is, so I asked the question, what are the fees on the Chase Sapphire credit card? RAG went, got the answer. Next question. What are the my points on it? Right
so
now,
it.
So now if I send what are the points on it to RAG retrieval, it's just gonna get back nothing. It's gonna get back any random stuff. But I needed to get back data regarding the Chase Sapphire card. That's why you need to rewrite the query once. So you could put an agentic model that rewrites the query. Then you create a fusion retriever. Fusion retriever is kind of like what Jatin was mentioning, right? You could have a graph at the back. So there could be multiple retrievals at the back, right? You could have a vector database at the back. You could have a graph at the back.
Could it be an SQL?
Yeah, it could be SQL table, right? So it's retrieving from these multiple sources, fusing them and giving it.
Okay.
Then you put a re-ranker.
Okay.
So re-ranker does what is basically it removes all the nonsense, because a lot of when you do retrieval, you try and retrieve a little extra, and a lot of junk comes in.
Okay.
So like a re-ranker agent will just go through everything and say, oh, okay, this is useful, not useful, this is useful, not useful.
Okay.
Coming back to your original thing, right? Too much context messes up the platform. So even when you're doing RAG, you still want to keep the context very clean.
Okay.
The minute the context has, rubbish in it, a chance of a LLM hallucinating, incorrect answer.
And the user just loses confidence.
Yeah, yeah, exactly. So you want to do that. Long-term memories is teaching the LLM certain things, right? Like vocabulary teaching.
Those jargons.
Yeah, certain behaviors, like don't do this in this situation.
Okay.
Like in the conflicting knowledge one, like, oh, if there are two parts of knowledge that are same, then at that point in time, use the memo.
Okay.
Orgs call it different things, right? Use the update circular.
Okay.
Give circulars preference over this. So those are where memories come in, where you can teach the LLM a bunch of stuff. And so you bring in long-term memories. What else do we bring in?
And this is the Fluid platform, right? This is the RAG of the agentic
RAG of Fluid. Yeah, where you just create the nodes. So conflict resolution is actually for conflicting knowledge specifically.
The master and the update.
Correct. And then you get the answer. Okay. So you create this step and you can define what's happening in each step. But all of this allows you to essentially have a really, really beautiful, high quality RAG output that handles some of those challenges.
Okay, got it. So we essentially solved all those 4 problems using this kind of RAG.
Correct. Here, like this is an example of like you can give it memories as well, right? So like let's say we create a memory that, even if you want to in a organizational situation, like what are different energy solutions we provide? Like if someone's asking a question like that, then give the answer, but also ask like what type of energy solutions do you want to know more about?
Right. So the challenge being the flow, right?
Yeah.
Because
exactly.
Yeah.
Like how do you create that journey or the flow
in a generative AI system?
Yeah. Absolutely. Okay. So now we'll kind of, let's say, ask it that question, and you can phrase it differently. The memory will kick in, as needed. And once it kind of gets that output, you will notice. So the RAG's given the output. At the end of it, it'll also ask that particular question. So now you say, please let me know if you'd like to know more about specific. What type of energy do you want to know more about?
Yeah.
So you're kind of teaching the language model to behave in a certain way at a certain point in
to
time.
Carry forward the conversation, not just an answer.
Correct. Exactly. We have an interesting question from Hasit. How does RAG handle structured data? So when it comes to structured data, what you typically want to do is add another agent. So the fusion retriever would probably be split into 3, one that's looking at the vector database, one that's looking up the graph database, and then the 4th one kicks in only like that you can put a model to decide whether you need retrieval from the database, but it'll take whatever question is coming in and create a SQL query for it.
Okay.
And then launch that SQL query in the back, get that knowledge, and then put that context in.
Got it.
So where someone asks a question like, how many loans have I given above $10,000 since 1st Jan 2024?
For a bank.
Yeah. So that the agent will first convert that to SQL, saying select star from X table.
And it'll figure out the tables also?
Yeah, so tables, the agent will have access to the table. So what columns are available in this table, what's the dictionary, all of that's given to
the dictionary. Okay.
And then you let it flow through.
Okay.
So then it'll kind of be able to answer that question very, very effectively. So you'll get that right context in, right? Oh, these are the loans.
And then the SQL.
And then the LLM presents it. Yeah.
Awesome.
So that's how that piece works. We had a question about how to overcome the document parsing problem, which is, let's see if we have something interesting on that. Yeah, so I will take that first and then I'll cover this since Kishan has already asked this question. How do you solve the intelligent parsers problem?
Those paragraph tables, images, 2 columns, 3 columns.
Exactly.
Yeah.
So I think there are quite a few interesting parsers out there. You can build your own parser also for certain situations that you want. So like a PDF reader parser, a docx parser. So I think build your own, take what's out there, and then hybridize the whole solution.
Okay, through some agent.
Yeah, like basically, like different parsers work for different situations. Most people get married to one parser. Like, oh, I'm going to use X parser. I'm going to use Y parser.
Okay.
But marry a bunch of parsers together.
Okay.
That gives you like, oh, okay, so this document has a lot, like multi-columnar document. Oh, unstructured.io does it best. So then I'll use that parser.
Okay.
But for this, maybe this one has nested tables, which unstructured doesn't deal too well. I've written something custom.
Okay.
So when it detects that, okay.
So it's not one parser, it's multiple. How do you decide? Who decides which parser?
That's typically a logic that you put.
Okay.
Like, in fact, some people even nowadays use LLM as a parser. Like you ask GPT 402
as a judge.
Just review. No, actually parse the document itself.
Okay.
Like read the document, convert this to text,
right.
Structured markdown text, and give it to me.
Okay.
So that's also a technique. So I think the decision of which parser to use, again, you could use an LLM to make that choice, but it's very expensive, so you would avoid it. So you kind of put more rules, like, checking if there's a nested table in it, checking if the PDF contains, or that page, page contains a lot of images, stuff like that. So you probably do it at that level.
And you go to page level?
Again, depends on the kind of problem. Page level is more expensive, but if needed for your accuracy, you kind of first see the accuracy. And if you say, I need to boost, then first do it at doc level. Performance is there, then chuck it.
In most cases, doc would suit.
Yeah. Okay. And then go down to page if needed.
And that's a 32% improvement, right? In RAG performance, if you just get parsing that.
Exactly. Okay. Then getting the right re-ranker, I think that's a good one. There are a lot of re-ranker models out there. Getting a good re-ranker in place helps a lot, for sure. NVIDIA is a really good one, re-rank QA Mistral 4B.
Okay.
What
does re-ranking mean?
Re-ranking is basically it goes through all the chunks that you've got,
okay,
for your, which you're going to give as context.
So queries come in, it's got multiple chunks going back.
Right, And so re-rankers just compares the question that you've asked with all the chunks and keeps asking the same question. Is this chunk actually related to answering this question? Will it help or not?
Okay.
And it'll give a score to each chunk.
And the best ones which go.
Yeah, so you re-rank and you put the best ones first.
Okay.
And then you knock off the bad ones.
Okay. So it's not just the retrieval, it's almost like a ranking then with what's most relevant.
Correct. Absolutely. So that's what a re-ranker does. Fine tuning, again, you shouldn't fine tune your models you should fine tune them for like comprehension capability.
Got you. Open book,
yeah. So give them open book samples and say answer this now, and you tune it for that. Don't tune it for the information.
Okay.
Don't tune it like XYZ is the percentage of interest rate, because then the percentage rate changes and the LLM hallucinates.
Got it.
Right. It doesn't hallucinate. It's just that it's remembered old information.
Sure.
And that's a pain to kind of keep re-updating and training, etc. So that's how you would solve for that.
And all of this is in the fluid solution, right? Right. Like we do all of this and that's how the performance is phenomenally more than regular RAG.
Yeah, absolutely. Yeah. I think too many people try to take like a LangChain or a Llama index, and they have some good RAG, they have some good RAG workflows. But if you just take the base one and you just run it, you get like 60-70% accuracy, and a pilot looks great. When you start to put all of the pieces together, you start to realize, it's to get that accuracy
97, 95. Yeah.
And that's where, if you want to just not take all that effort of, building all those layers, and then, how to optimize, how to handle LLM, or model performance, tuning the models, getting the right models in, creating the, fine-tuned data sets, and then the right re-ranker models, hosting them, letting them run for scale, all of that, and then sequencing the whole exercise so that it works. Then you just use an enterprise solution like Fluid GPT that can help you get there faster. But yeah, even building is not a bad approach. It's just that it's a lot more painful than you realize, because the fundamental problem is that when you're doing evaluations, it looks like it's very tough to evaluate whether you're on the right track.
Got it. It's a journey.
You need the right source of data, you need the right examples, you need to get an eval set, and that helps you do it a lot better. Someone's asking, is there a way to develop that's Vedant self-evolving architecture that dynamically reconfigures the knowledge retrieval and generation mechanisms? Possible, very complex to know, like for the model to know whether the changes it's making are good or bad. Because like you have a good test set and then you need to test against that set. Right? It might make a change for one situation but screw up 10 other situations.
Okay.
So I've never now seen a good state-of-the-art system that can do it, but it's an interesting approach, slightly expensive. And I think we had one more, which is, are there RAG agent? That's from Harshit. Are there RAG agentic generators available which will work on logic written in English following a semantic pattern? Oh, so you're saying that like you literally give it like instructions to do these steps, like, oh, do a re-rank, do this, and it does it. Nothing that can just run off like
pure English. Yeah. Can it run on pure English?
No, not yet. Because it's still doing a lot of structured things.
Okay.
So the pure English one, the performance will be low and it'll be very slow. Because it's literally every time thinking through the steps it needs to do. So you'll get a lot of
pushback.
No, in production you'll get a lot of variability of performance. Like sometimes it'll do a phenomenal job, sometimes it'll do really bad, and it'll be very slow.
Got it.
So that will become a problem.
The consistency.
Correct. Ree has asked a question, lovely name. Can you explain more on how to fine-tune, not like a mugger? So it's essentially the training set that you give. You can't give it a training set of like, here's the data, now just learn this. You should have it like, you should simulate RAG. So saying, okay, here's a question, like how do I do X?
Okay.
And in the training set, you give it the examples, and then you say this is the right answer.
Okay.
So it's learning how to pick the right answer from the context. Yeah, derive an answer from the context.
Okay.
So that's your training set, as opposed to this is the question, this is the answer. This is the question. Yeah. This is the question. This is the context. This was the answer that came out from that.
So you're almost training it to be a better learner rather than a fact.
Correct. Exactly. You're not teaching the facts. Yeah, so this is an example of once you get that running and right? Like when it's reading images, you're converting the images also to vectors intelligently. This can allow you to do some pretty cool stuff.
Right? So it's answered a very complex diagram, right? The source of the information it answered right now was from this kind of table.
Right, this table.
Right.
And so part of the answer came from this table, and part of the answer came from this diagram in that same document, which is extracted out. So
I've just seen the number of lines.
Yeah. So it's very powerful, right? Imagine if it's then now being able to search all of this, get the understanding, get the context, and give you.
Yeah, because there's so much information, especially in finance, in manufacturing, in tables, in diagrams, right? And that needs to be parsed, right? And you can't just have a regular parser doing it.
Yeah, absolutely. So coming to the next part, which is, this is a lot of fun. So agentic models, right? So we just covered a brief on RAG. The only other, I think one thing that we missed, this was one, is that, you should definitely test out different models, because sometimes...
Different large language models.
Yeah, different LLMs. Even if you're doing agentic or non-agentic, because you tend to see very varied performance. Like this is a same RAG. What is the fees on the Chase Sapphire Reserve card? And on the left, and this is something the Fluid GPT platform actually has a cool feature where you can do comparative models, like one model on the left, one model on the right.
Also Mistral and Llama running. Yeah?
Right. Okay. Or you could do, even other variants like internet search on the left and knowledge base on the right.
Okay, so they've answered both correctly, but Llama's just gone ahead and given some more context.
Yeah, right? So like think about it. Right? Look at this. On the left, you have Llama 3.2 11B.
Right.
So newer model, but much smaller, only 11 billion parameters.
Okay.
On the right, you have Mistral's mixture of experts.
Okay.
8 multiplied by 70, so 56 billion parameter model.
Okay.
With the mixture of experts driven on top. And I mean, personally, as a user, I prefer the left side a lot more.
You just got a little more context. Right? Foreign transactions.
Someone might prefer the right, so you choose the model. But I think a lot of people would be like, oh, wow, the 3.211V gave me a better answer, more nuanced, more details, higher quality, and much lower parameters. So I can like run this on an L4 chip as well, and NVIDIA L4, which is dirt cheap. Whereas the Mistral will now need an L40S or a H100 to run. So lot lower cost and better quality answer.
So it's not about just thinking it's GPT-4o, right? It's about put it out there, let it run, and Fluid Stool in fact is allowing you to just compare. So you can just sort of say, hey, this guy's doing a better job. Let's use this LLM.
And these were vanilla models, so that's actually quite cool. Margarita has asked the question: is it possible to use an SLM? I guess it's a small language model. So these are called distillation models, where you can distill information from a large language model into a smaller model. It's a newer technique that's come out, very interesting. But we've seen that distillation models are better for specific use cases like function calling agents. Or like text to SQL, where you're literally distilling just the text to SQL knowledge part of the model, of the larger model, into the SLM. They work better. RAG tends to be very generic in like the challenges could be different each time. So trying to distill that knowledge into SLM is very hard. So I would avoid it for the SLM. For RAG, but for if you're doing like a text to SQL agent, function calling agent.
So more agentic side.
Or more specific use case, like more narrow, like narrower use cases, like mathematics heavy use case. There you could still try an SLM.
Got it.
So so fun part. What are agentic models? And what are they all about? And we're going to show you an actual live demo of putting an agent together and seeing how it runs. Agents are essentially more goal oriented, right? So you're giving the LLM kind of a goal, or like, hey, I want this to happen. Like, I want to achieve this, and you figure it out. And it'll kind of run, and you can give it like a set of capabilities, like and those are called tools. Right, like so, it could have an internet tool, it could have a knowledge-based tool, it could have other tools. So RAG, like if you look at and then you say, okay, solve this problem, and it'll try and figure out, okay, to solve this problem, I need to probably search the internet first, then I need to use my own brains. And then so like the
pre-trained knowledge.
The classic, the first example that came out of Agentics, if a lot of you might remember this, was I think it was to do with what is Leonardo DiCaprio's girlfriend's age raised to the power of 16?
Wow.
Right.
I don't know why anyone wanted that answer.
So like an LLM will be like just spit out rubbish at that point, right? It'll just go and be like, it'll guess the answer. It'll just guess a bunch of digits and say this is it, and it'll be probably absolutely wrong.
Right.
In fact, you should try this with GPT-4. I've not tried this with 4.0 directly, but I think it'll not do anything great. The agent would go like, okay, I need it'll kick a thought like
stepwise.
I need to solve this problem. So first thing, I'll break this problem now. I need to know Leonardo DiCaprio's girlfriend. Who is she? So then I'll use the internet, and I'll use the internet tool for that. So they'll send the internet tool, hey, Leonardo DiCaprio girlfriend search. Then the internet tool will come back with info. They'll read through it and realize, okay, this is the one. Then puts her name there. Now next search her age. So go back to internet tool. This one's age. Gets her age. Now he needs to do this to the power of 16. So a math tool. So then I'll say, okay, I can use a math tool. Sends this to the math tool. Math tool does the calculation, gives it back. LLM presents the answer.
Awesome.
So the agent's more goal-oriented. It's not like prompt answer.
And at times it's conflicting information, right? Loses current because the internet may have multiple sources.
Correct. Then deciding.
So even the conflict resolution is built in, right?
So if the agent's really smart, it could even be like, oh, okay, there are two girlfriends come up now. Who's the current one? So let me put a search for the current one.
Right. Or maybe like if you ask searching for age, and there's an old article which mentions an extra age, and now she's older or younger, whatever.
Correct.
So again, the conflict resolution.
So that was Agents 1.0.
Okay.
This is another part to it actually, which is quite interesting. So that was Agents 1.0, which
Right.
is like we could do this phenomenal.
Okay.
GPT-O1 is based on this logic, this chain of thought thinking.
Chain of thought.
Yeah, it's called chain of thought thinking.
Yeah.
Then they said the LLM would still struggle through it, right?
Okay.
Because it has to do all these steps. So it works, but not in like situations would get confused, would not take the right steps. So like, let's break the problem down.
Break the problem.
Yeah,
Okay.
Instead of one big agent that's doing this,
Yeah.
let's have different agents.
Okay.
So one agent is called the internet agent,
Right.
which is just getting requests, researching it on the internet, figuring out what's right, what's wrong, and then sending it back.
Okay.
Then there'll be one agent which is, just planning the whole activity.
Okay.
Like, okay, what all steps I need to do. So you can break the task, and we'll show you an example of this actually.
Okay.
So you can break the task down into different agents that are specialized.
All right.
Kind of like how the agentic RAG that we showed you, right?
Got
Different agents are specialized rather than one LLM trying to do
everything.
Yeah. Not even one LLM, but one. Like,
So it's almost like a team.
yeah, like a team.
Versus a single.
Yeah, and they're talking to each other and they're deciding who to send the request to.
A team of specialists.
Yeah. So like they'll always sometimes there's a team leader agent that's just deciding who should be working next.
Okay.
Kind of like an organization, right? Like a team working together, a team leader. Like,
So I have a question. Do we see an AI CEO in the future?
yeah, absolutely.
Yeah.
I mean, you already see them here. I
Okay.
guess as they get smarter, they could replace the CEO.
God.
But not yet as of now. Someone is okay, Kishan. I think you've asked due to hallucination. I guess you probably asked at a certain point in time, so we'll need a little more context. And Yuvraj has asked if agents depend on memory for decision making, the inference machine a portion is dedicatedly allocated, something like that. Yeah, so something like JVM. So basically, I think the question is around how do these agents know what's going on. So there's something called agent memory. And the memory of the agents, like what all has happened so far, what research has been done, that's all given to the agent as text.
Okay.
And they have to keep the memory a little clean. If you overload the memory, it'll start to get confused.
Okay.
So there's a way or technique of maintaining the right memory so the agents know what's going on.
What's going on?
Right. So again, challenges here: routing to the right tools. Too many loops, it gets caught in infinite loops.
Okay.
It needs to run fast, right? So you should probably use something like a Nemo.
What is Nemo?
Nemo is like a inference. Nemo is like a library by NVIDIA,
Okay.
Which allows you to speed up it's called. They have these containers called NIMs, which are a little more optimized for NVIDIA.
Okay.
And they essentially, so Nemo is a framework that allows you to speed up a lot of the LLM running and tuning that you're doing.
But
Because they've kind of built these special functions that can talk to the GPU a little better.
Okay.
And are more optimized for that, essentially. We'll come back to this Snowflake agent. Yeah, so let's show you an example of agents. There's a question by Margareta. Are there any known techniques to make agent workflows more energy and compute efficient? I think having agents that give shorter outputs, shorter, cleaner outputs, that's probably the best approach. Nothing major. I think the same challenge as LLMs, right? Using something like a Nemo, more energy efficient. So things like that can help for sure. For dynamically adding tasks, do we need a master task list? This is from Shiv. Yeah, you could actually have and that's what the first generation of if you heard of Baby GPT and Auto GPT,
Auto GPT,
they were all the rage last year. They were this concept that there'll be a task, then there'll be a planning phase where the agent will figure out to achieve this task, what are the tasks it needs to do.
Okay.
And then it'll create a task list. And then it'll just start going through the task list one by one.
Okay.
And then each task could result in more tasks.
Okay.
So it's like going through it step by step.
And then it's again.
Yeah.
Okay.
Really cool concept. Got a lot of popularity on GitHub and all. Didn't take off enterprise-wide like it should have or like people thought it would. Two problems. I think agents will get caught in infinite loops.
Infinite loops.
Yeah. It would take a wrong task direction.
Okay.
So it was a hit and a miss, right? Like 60% of the time, yes. 40% has gone totally haywire.
There's a lot of compute as well.
Yeah, a lot of compute, a lot of cost. and then it doing the tasks like if it's kind of just coming up with its own tasks and doing it, there's a lot of risk, right? It sometimes do the wrong. Like if you're telling it, oh, email all my come up with a marketing campaign and send it out to folks.
Yeah.
Like it screws up the first part, then the second part there's no validation.
There's too much risk.
Yeah, there's a lot of risk on what it does. So I think that's why a lot of these didn't take off, but very promising concepts. So here we've kind of done something fun. We've taken a planner agent. Let me just open it up. So you can just create an agent.
So this is up to Fluid AI's agentic platform.
Okay. Correct. So in that you have a planner agent. You kind of give it like what to do. So we said, okay, break it down into 2 parts. It syncs with your LangChain Llama Index. You can actually tell it to use a particular agent type. So you've given it a prompt. You can give it access to tools like knowledge-based tool, internet tool, whatever.
So I can decide whether I want to have internet access or the
correct
knowledge-based.
Yeah, or multiple tools. You can create as many. Which model to get access to.
Okay.
So you kind of have the agents. We have a planner agent. We have a researcher agent that goes on the internet. We have a newsletter agent that creates the newsletter. We have an email draft agent that goes ahead and creates an email. So let's go ahead and actually run one. Any interesting topics from the past that you'd want to?
Anything? Shall we talk about the American election or?
But that's kind of it'll give like a very it's too generic a topic.
Right?
Maybe let's have it research on. Since we talk about agentic models, right?
That's good.
Yeah. The rise of agentic AI models and approaches. Generative AI. Right. So let's fire that. So what it's going to do essentially is so the agents have all kicked off. So it starts with the planner agent.
So what's the planner agent do?
So it's just coming up with the plan got to be done. So it's taken this and broken this down into 2 parts of the topic, right? So one is understanding agentic models.
Okay.
And it said the other is approach to developing agentic AI.
So it sort of said, okay, you give me something, I need to break it down to pieces.
Correct. Yeah, exactly. Right. So it's saying, okay, I'll talk about the definition and the characteristics of agentic models. Then I'll go into the approaches, technology frameworks, and then the ethical considerations behind it.
Okay.
The researcher agent is now gone and done research and actually generating in real time, right?
So it's gone online?
Yeah. So it's already done. So it's actually quite a fast series.
Okay.
But so this one's gone online, done research online.
Okay.
As well as its own knowledge.
Right.
And it's kind of
the pre-trained.
Yeah. So it's taken what the planner agent told it to do.
Okay.
And then started researching those topics. So here's the understanding of agentic models are defined as autonomous systems capable of independent blah, 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 blah. Applications and examples it's given, then approaches to developing it, the ethical considerations.
From the planner, right?
Yeah, from what the planner told you to research.
Yeah.
I just kind of put this together. And then the newsletter agent is now kicked in and said, oh, let me make it a fun newsletter.
I can see the emojis.
Yeah. So the future is here, exploding AI, agentic AI models, steer business leaders, so the newsletters that can go out.
Right.
And so now it's structured, right? What is agentic AI? Transforming creative industries, navigating ethical waters, the technology behind it, and how does it work?
Oh, so I think we can just send this, right?
Yeah,
to our subscribers. Yeah.
Absolutely. And then it's created an email version of it as well.
Okay.
So
with the subject line and all of that.
Yeah. So one was a newsletter style email, one was that. Yeah. And again, it's just an example. So you the world is kind of your oyster when it comes to these agents, because you could tell them what's to be done and what you wanted to do, right? So the email draft agent, for example, we said, okay, summarize this, and here's where that memory comes to really useful, right?
Okay.
So this agent, the email draft agent, is using the outputs of the newsletter agent to come out with. Right? So here we're giving it the memory of the newsletter agent.
Okay.
Saying use this to come up with the output. If you looked at the newsletter agent, it's using everything from given below the research by the research agent. And this was the plan that was generated. Now use this to generate your newsletter. You could give it more details if needed. So that's how like the memory is transferring between these agents.
Okay.
And I know there was a question on memory. Then the agents kind of memorize, go ahead, and then you're done with outputs like this. But yeah, this is just an example. You could have agents that do complete automation, like
KYC.
Yeah, like KYC, or even like, hey, like schedule a calendar and then use Google Calendar's API to actually punch it in there.
Got it.
At the end, right? So that's the scheduling agent.
Right.
Right. So one is checking your schedule, one is actually hitting the schedule
and blocking
the calendar. So that kind of stuff. There's a question from Murtuza, which is, what are your favorite agent frameworks? LangGraph, Crew, Llama Index? Do you build your own? So yeah, I think there are a lot of agentic frameworks. We kind of built our own, but all are nice. I think each one has a little bit of nuance. Like
horses for courses.
Yeah. So LangGraph's more, by the very nature of the name, very graphical, like a diacyclic graph. So it's like literally a graph. Whereas Llama Index workflows are more like event based. So they're more like asynchronous, and they kind of fire up. Like each agent gives an event, and then another agent decides whether it needs to respond to that event. So it's very unique the way they've done it.
Okay.
Crew has gone with more like a.
That's a cool name.
Yeah. Crew's gone with the name key. Like there's this team, like there's a master team leader, and then it has little teams, and then it's kind of deciding who to send to. Okay. So very non-linear in their approach, but more like agentic teams. So yeah, again, very different. You kind of put together the best of all to kind of come up with a super agent that can do a mix of everything. What are different use cases to take LangGraph or Crew? Yeah, I think this by Shiv. We kind of covered a little bit of it, but yeah, I think if you have like a very like a flow journey, then LangGraph better. If you have something where the agents need to think through and come up with ideas and then, keep talking to each other, like research and stuff,
okay,
Crew would be a better bet.
A better tool.
Better bet for that. This is Kishan, what are the most effective techniques for quantizing retrieval-augmented generation models to enable efficient deployments? Interesting question, a little different from what we were discussing. So quantization is essentially
what is quantization?
Yeah, it's a technique. So see, you have a large language model. Two things will slow it down. One is the model needs certain amount of GPU memory to host it.
Okay.
So if you have 48 GB of RAM, GPU memory, right? Let's say L40S has a 48 GB of memory, and you want to put a 70 billion parameter model in it.
Okay.
That needs more. Needs more memory. It needs like at least 70-80 GB of GPU memory.
Okay.
So you can't put it in. Now all these LLMs are written in 16-bit floating point.
Okay.
So you can basically say, okay, I'll just not like every parameter in the LLM is 16 bits. So I'll say, okay, I'll just round it down to the 4 bits or 8-bit quantization.
Would you lose some accuracy?
You just round it off.
Okay.
Yeah. So you round it to the closest decimal.
Okay.
So with 16 decimal places, you round it to 8 decimal places.
Okay.
But in bits, so it's not exactly 16 places. But
got you.
So you'll do that, and then you'll lose some performance because now it's rounded down, right? Mm-hmm. So when the LLM multiplications happen, they'll not happen as accurately.
But are compute efficient.
Yeah, so you'll use a lot less GPU memory. It'll be slightly more, inference probably be faster, a little heavier in terms of like there is some compute components to it as well. Overall, good technique for most LLMs do well with quantization.
But
you can host a higher parameter LLM in a smaller space.
All right.
That's it. Yeah, so this is like how the agent framework looks and works. Yeah, essentially. How can AI? This is a question of understanding. I mean, the stupid answer to this is you probably put an ethics agent at the end, and then the LLM
something's trained on ethical.
And then that LLM that agent tries to ensure that the output is ethical and
within your ethical framework.
Within your thing, and Another approach is to put like a prompt shield which is like a faster version of an agent. Right?
Prompt guard?
Yeah, prompt guard or shield, which does it faster. This is an example of this. Okay, let me.
Oh, this is kind of Snowflake.
Yeah, so Snowflake, like this is a text to SQL example, right? An agent that's so first the query goes, then there'll be a text to SQL agent at the back. Okay. Then that'll get the data, then it'll send it back to the responder agent. And a question like,
speed up.
Yeah, give me the average balances for each job type.
So there's a bank, hundreds of job types, needs to know average balance.
Right. So now the agents ran, it's given an output. And now you could also actually send it to another agent, which is like a visualizer agent. Now, just for the demo, we kind of separated the steps. But you imagine lead agent deciding, oh, do I need to visualize this? Would it be useful? Yes. Okay, send it to the visualizer agent.
It's gone into a histogram.
Yeah, and then it would probably tell the visualizer agent, hey, I want a histogram for this data.
So you want, in this case, the human is quite involved.
Correct.
But the steps is
multimodal. So how do you get multimodality, voice, image, video into some of these agents? So with voice, the problem is how do you get really high quality or really low latency and high quality of voice? That's always been like a key thing, right? Because these agents are thinking at the back, customers asking a question in the front. Can it do it faster? So OpenAI has launched something called real-time audio, which means that instead of doing the classical
voice to text,
and then text to then text back to voice. It just does voice. The LLM understands voice and then generates voice back.
Yeah.
Problem is that it's really expensive. So
if you're doing 10,000 calls.
10,000 calls, 100,000 calls, 1 million calls. It just because it blows through your budget like anything. So you'd rather still do the other layer. But you can build a lot of cool efficiencies in it. In fact, I think this one has audio, so we'll try and show it to you.
You can share audio.
Yeah. Oh, you can?
Yeah, you can just go here.
Sorry.
Yeah, you have to go. Right, here we go. And you click on share video.
Yeah. Okay. So the audio call.
What that looks like. You just call her up.
So it's stop sharing my slide.
Call her up.
Yeah. Disable screen share. Yeah, so everyone can see this now.
Hi, how are you doing?
I am good. How are you?
I'm doing really well. What can I help you with?
I was wondering if applying for a credit card will affect my credit score.
Sure, I'm looking it up. Anytime you apply for credit or a loan, the creditor will order a copy of your credit report, which is known as a hard inquiry. Having multiple hard inquiries within a short period of time
And
may
which travel card would you recommend?
Let me see what I can find. Based on customer reviews and benefits, one travel card that is highly recommended is the Chase Sapphire Preferred Credit Card.
So that was like a classic example of like an agent that is running at the back, running voice to text, and kind of doing all of those layers really well.
Yeah, and you could interrupt it. It was lifelike.
Yeah.
So I can imagine talking to somebody in some support center and just being, that does the job for me.
Yeah, absolutely. I mean, at Fluid AI, GPT, we're doing a lot of these implementations where, it's automating the calls. And so the agent, and maybe you will want to talk about that model, the 3 or 4 tier model.
Yeah, we definitely talk about that. And, again, these work really beautifully on NVIDIA architecture.
Yeah. So the faster that you can make them so that the latency goes down essentially.
Yeah. So many, optionalities, right? With both RAG, Agentic AI, how do we select the right use cases? This is a small framework we've come up with. I know we're already at time, but very quickly, you look at feasibility, you look at business value, high highs, that's the likely wins, right? So high business value, high feasibility, that's where you should be typically playing. And then you can go on to maybe high business value, low feasibility, where the technology keeps on improving. That's the calculated risk. So that's the area where anyone should be playing if they're looking at implementing Gen AI use cases, both in agentic and in RAG. And use cases can really evolve from low risk to high risk and low value to high value. So in the call center agents, right, that's where we really took this forward with particular financial institutions. We started with assisting the humans, right? The human support agents had an AI chatbot assisting them with the queries the users were pushing them. That then evolved to an email agentic AI, which can respond almost 90% of the emails coming in. We then took it to live chat, where it was synchronous, and then we took it to phone support. Abhinav just showed you an example of that. So it was an evolution over 6 months. We kept on increasing the risk, and the value kept on increasing as well. But it was a beautiful journey because at each step, we could stand back and say, hey, where's the agentic AI model working? Where's the RAG sort of failing? And keep on tweaking things in a more low risk environment.
Yeah, absolutely.
Build versus buy. I think this is one of the last slides I want to.
Yeah. No, I think it's a very, very critical question. Right? Do you build the technology yourself, or do you buy from a vendor? And how do you go about that, right? So you could take an open source library like a LangChain or a Llama Index and build a great RAG or basic agentic system with 65%, 70% accuracy in 2 weeks, right? And then hitting 90%, this is where we also kind of didn't realize, can sometimes take you years to hit 90 plus because of all the nuances that we just talked about, right? So if you feel you have a skilled team that can dedicate time to this exercise, then build could be a great option because you have more control. But then you want to augment that team with the right trainings, right training, education, the right source code patterns, that they can buy, and the consulting, so that they just do it much faster. Right? So what could take them years takes them 2-3 months. Otherwise, it's a project that can die very fast in a large organization. So that's something we've helped a lot of organizations with. Just the right source code patterns, the right trainings,
consulting.
Yeah. The other approach is buy, where you can just get off the ground very quick, right? And this is ideally the fastest way to value, because you can be up and running in week 1, start testing, piloting. Because what most people don't understand is in the build journey is that build is only half the challenge, right? You build the AI, build the agentic model, you build the RAG, it's optimized, it's finally working, let's say after a year or 6 months with large team expenditure. Then you come to, the use case, the user behavior changes. How will it work in the real world? So then you go through all the deployment challenges. So you literally just exhausted yourself, come out and said, I finally won. And then realize there's a full new maze that's
to go through.
So that's where the buy journey takes you straight to that part, right, of the challenge, which is useful. And don't just buy just basic RAG in a box, right? Don't buy something that's just like someone's put together a very simple system, no re-rankers, no table parsing, no image parsing, no agentics, no memory.
That's going to be a long, painful
journey. Vocabularies, right? Yeah, it's a journey where you're headed for death, because essentially at the end of it, the demo will look good, but when you start putting it into production, you'll run into those actual challenges, and then there's no way to solve it because the platform you bought doesn't support any of it. So I think search for that. Platforms like ours do that really well. And then the second is look at data security, right? Can it be on-prem, if needed, if it's or in your private clouds, or hybrid deployments where the data rests with you. That's a great way of ensuring data security with the vendor and getting compliance sign-offs really quick. Okay. And I think that combo,
speed to launch.
That combo works really, really well.
Awesome. So I think, I think we've talked about hosting everything locally. That's possible. It can be done on NVIDIA architectures as well. And compliance is faster, full privacy, etc. So, so I already talked about this limited support agent capacity. We moved these guys. They use the Agentic AI platform. And now about 50% of inquiries are being handled with AI end-to-end. There will be 90% at the end of the year. So fantastic, right? RAG plus Agentics, taking a small company with which had 500 agents actually, not a small company, a fairly big one. And has now enabled them. They never need to grow that number, and they're doing 90%. Awesome. So I think we
have a few questions.
Right.
If you want to take close them out really quick.
Sure. Why don't
or if you have something to cover, we can.
No, I think we're good. Maybe we can just tell people a little bit about our community as well, and we can take the questions.
Yes. So I think if you want, like, if you found this interesting, or you're generally interested in what's happening in the Gen AI enterprise space, we have a Gen AI enterprise community. You can just scan the QR. It's available on WhatsApp, and then you can join it, and we keep doing latest updates of what's happening within Gen AI enterprise. And all the cool action that you can leverage off of. And now we get to some of the closing questions. So Murtuza had a really interesting one. How does Nemo compare to Grok? Very interesting question. Yeah. So Nemo is a great framework. So essentially, what are they both solving for? Right? They're both solving for better performance and better speed at the time of inference of these language models. But they're very different approaches. So Grok has said that Nemo is trying to do it at the software layer. Grok is trying to do it at the hardware layer. Nemo is saying that we're taking, you already have the NVIDIA chips, which is standardized hardware. Can we build software that talks to the hardware a little better for faster inference? Okay. And that's how they're solving it. So you'll get only a certain amount of optimization is possible there. Grok has said we'll just change the hardware. So GPUs are very general purpose, right? They can be used for gaming, 3D animations, Bitcoin mining, exactly. All these kind of use cases. Grok uses something called an LPU, which is a completely different type of chip built only for language models. So that's how they kind of work, right? This language processing unit. They're built to only do LLM processing, which is why they're far better than a GPU. But then you can't use them for anything else. You can't expect it to do do the graphics or the video rendering on your laptop.
Sure. It's a large language chip.
Yeah. So you can get like 5 to 10x better output, sometimes even 50x better output on an LPU to a GPU because the hardware has changed. The code is written into the hardware, the approach. Problem is that you have to, like, a lot of the out-of-the-box stuff doesn't work. So you have to use Grok's API. You could buy the chips, but then, coding them, making them work with the language models, it's quite a pain. So if you're using them as an API, then they would be a great person to use for like just faster, lower cost inference for sure. And because it's faster, the cost comes down considerably because you're using less compute time for the same request. The next question by Hasit is there a standard for two agents to talk to each other? Not yet, but a lot of people are working on different standards. Like the easiest standard for two agents to talk to each other is literally English. Like the agent can say, what is the message you want to send to the next agent?
So you move from binary to English, 50 years.
Which is quite cool, right?
Yeah.
So like the next agent just telling him, hey, research these topics and come back. And then that agent's like, okay, I'll do this.
No APIs, no nothing.
It's like literally a team of people. There are more sophisticated approaches coming. Like also you could use function calling as a way of communicating to the other agent. Or you could have sometimes the agents have memory stacks, a commonized memory between the agents of what they're solving for. So everyone's writing to a common memory.
Okay.
And that's the way agents are kind of continuing the task forward. So that's the way they can talk to each other. Jatin's question is, can Agentic RAG help extract key information from documents, or is it overkill for this purpose? I would say it's only overkill if the standard technique isn't working. Is working, sorry. Yeah. So if you try the easiest technique, single LLM
that's prompt, typically only if you have very easy document.
And if it's giving the wrong answer, then you kind of go more complicated. So yeah, approach it the other way essentially. All right, perfect. All right. I think we're done. So this was fun.
Thank you so much for joining us today. We'll be doing another webinar early December. We'll be talking a lot about Fluid's platform. Especially today we talk generally RAG and Agentic, but we'd love to take you much deeper into it. We have a lot of bells and whistles. The version's just launched, and we'd love to show you guys, and just keep looking out. Do join our community. We do keep sharing new ideas, And we have an AI day coming at the office, right?
Yeah.
So in Bombay, Saturday,
Yes.
We can share the link with everyone. And if you're in Bombay, please do drop by. We're discussing AI.
Absolutely.
Awesome.
All right. Thank you all. Take care.
Thank you.